Today we're going to continue with section 7.3. We're going to use formulas involving sides, angles, and diagonals of polygons. So just a quick reminder of what our three formulas are. Remember, the sum of the interior angles of a polygon, with n representing the number of sides, or n could represent the number of angles, is n minus 2 times 180. If one exterior angle is taken from each vertex, then the sum of all those exterior angles, regardless of what kind of polygon we have, will always add up to 360. And then D, representing diagonals, where n is the number of sides or the number of angles in that polygon, we get diagonals from taking n times n minus 3 and dividing that whole product by 2. So let's use this information to look at some example problems. It's asking, what is the name of the polygon if the sum of the interior angles is 1080 degrees? Okay, so notice that in this problem, they're asking for the name of the polygon. In the last lesson, I was always telling you the name of the polygon, and we were figuring out the sum of the angles. So these types of problems are actually working backwards. I don't know what n is, but if we're talking about sum of interior angles, well, remember, that's the formula, that n minus 2 times 180. So because I don't know what the polygon is, I cannot substitute anything in for n. However, they are telling me what all of the angles add up to. So they're actually giving me that s sub I. So we're going to set up an equation where 1080 is going to equal n minus 2 times 180. And now we're going to solve for n. So in order to solve this problem, I got to get n by itself. There's a couple different ways we can go about doing that. We could technically distribute the 180 to everything in parentheses, but maybe a faster way would be, because 180 is being multiplied, how do you undo multiplication? We divide. I'm going to divide both sides by 180. So 1080 divided by 180 is going to give us 6. That's going to equal n minus 2. And now I no longer need the parentheses because there's nothing being multiplied by that. So now I have one more step to solve for n. I got to get the 2 to the other side. I do that by adding. So 6 plus 2 is 8. So 8 represents n. So 8 is the number of sides. That's not my final answer because the question says, what is the name of the polygon? So now we have to think about our vocab. What's an 8-sided figure? Well, that would be an octagon. So an octagon would be my final answer. Okay, this problem says, name the polygon if the sum of the interior angles is 2,520. So same idea. Sum of the interior angles is using the formula of n minus 2 times 180. Because they want us to name the polygon, we do not know what n is. But I know that all of the angles are adding up to this 2,520. So that is the sum of my interior angles. So I'm going to substitute that in. 2,520 is going to equal n minus 2 times 180. Once again, I think the fastest way to then start solving for n is to get rid of the multiplication. So I'm going to divide both sides by 180. That would then give me 14 to equal n minus 2. Last step to get n by itself is to add 2 to both sides. Well, 14 plus 2 is 16. That is how many sides we have. Once again, the question says to name the polygon. 16 is the number of sides. Because this is not going to be a particular vocab, we would just say 16 gone. And there is my polygon. Same idea, name the number of sides if the sum of the angles, so notice that they didn't specifically say interior, but if they were talking exterior, they would have to say the word exterior. So if they just say angles, sum of the angles, we're talking interior angles. So once again, sum of my interior angles would be that n minus 2 times 180 formula. This time, they are telling us that the sum is represented as this expression of 180x plus 540. So that's going to go in for S. Because it says name the number of sides, once I find n, I have my answer. So we're going to have 180, x plus 540. That's going to equal my n minus 2 times 180. Just like our last two problems, I'm going to get rid of the multiplication by dividing. Now, because I divided the right-hand side by 180, everything on the left is going to get divided by 180 as well. So on the left-hand side, 180x divided by 180 is just x, plus 540 divided by 180 is going to give me 3. On the right-hand side, that would leave me with n minus 2. So to find the number of sides, I got to get n by itself. The last step to get n by itself is to add 2 to both sides. So n is going to equal, if I combine my like terms, it's the numbers that I want to combine. I still have an x. 3 plus 2 is 5. So it looks like x plus 5 would be the number of sides in this particular problem. All right, here is another example. It says, name the polygon that contains the following number of diagonals. So this time, if we're talking about diagonals, we have to know what the formula is. Remember, diagonals is n times n minus 3 divided by 2. If they're asking for us to name the polygon, that means that, once again, we do not have n, but they're telling me how many diagonals. So that 27 is represented as D. So we're going to set up the equation that 27 is going to equal n times n minus 3, all divided by 2. Now I want to start solving for n. So on the right-hand side, because everything is being divided by 2, I'm going to get rid of division. I'm going to multiply by 2. So if I do that to the left, if I do it to the right, I'm doing it to the left. So the 2's get to go away. 2 times 27 is going to give me 54, and that equals n times n minus 3. I want to get rid of the parentheses. Notice that because n on the outside is being multiplied by the parentheses, I'm not going to divide by n because then I would have an n on both sides of the equations, and my goal is to keep the n's together because we want to solve for n. So I'm going to distribute this time. Well, n times n is n squared. N times negative 3 is negative 3n. In this particular problem, because there is a squared term, a variable that doesn't have an exponent, and a number, this quadratic means that we are going to want to try to factor. So in order to factor, I got to get everything to one side. I want the n squared term to remain positive. I don't want to turn that to a negative. So since it's already positive on the right, I'm going to move the 54 over to the other side by subtracting. So that gives me then 0 to equal, none of those are like terms, so we'll have n squared minus 3n minus 54. Like I said, this is going to be a factoring problem. I always want to look for a GCF when I'm asked to factor. So a GCF is, what do they all have in common? Well, there's technically a 1 in front of that n squared. The moment all of those numbers, if one of them is a 1, that's going to be the biggest number that they have in common. And taking out a 1 is not going to change the numbers. If I look at all of the terms, not all of them contain a variable. The 54 doesn't. So I checked, but there is no GCF. So with no GCF and us having a lead coefficient of 1 in front of that n squared, our thought process should be, what is going to multiply to the last number, but add to the number in the middle? Okay, so we're thinking about numbers that multiply to negative 54. So if it helps, maybe start making a table. So what are some numbers that multiply to negative 54? Well, because you're multiplying to a negative, one of those numbers is going to be negative and one of those numbers is going to be positive. So multiplying, notice that it is an even number, so technically 2 would go into it. So if I make 2, then it would have to be negative 27, because 2 times negative 27 will multiply to negative 54. If I then add those two numbers, I want to get a number of negative 3. Notice that that's going to give me negative 25, which is definitely not the number that I want in the middle. So while I found two numbers that multiplied to negative 54, they're not going to add to my middle term. And if I try to switch the signs, it's not going to get me any closer to getting negative 3. So let's think about two more numbers that multiply to get me 54. Well, one of them would be 9 and 6, but I would need to make one of them negative and one of them positive. If I make the 9 negative and the 6 positive, that will multiply to get me my negative 54. Notice that when I add those two numbers, negative 9 plus 6 will get me the negative 3 that I'm looking for. So that means it's these two numbers that are going to be in my factors. So we're going to be creating two things being multiplied together. It's still an equation, so it's still going to equal 0. Because n squared starts that trinomial, that means that we are going to want n to start each of those parentheses, because n times n is n squared. We know what our numbers are, so the negative 9 is going to go in one of the parentheses, and the positive 6 is going to go in the other. Now that I've factored, I'm going to set each of those factors that contain a variable equal to 0. So n minus 9 equals 0, n plus 6 equals 0. I'm going to solve for n. So in the first equation, that means adding 9. In the second equation, that means subtracting 6. So we have two different values for n. Well, remember, n is representing the number of sides of a polygon. There's no such thing as a negative number of sides. So in this case, negative 6 does not make any sense to us. Only the positive number does. But now 9's not my final answer either, because it says to name the polygon. So a 9-sided polygon, we name that as a nonagon. So a nonagon would be my answer. Let's take a look at another example. So same exact thing, we're going to name the polygon that contains the following number of diagonals. We want to know what our formula is. Remember, n times n minus 3 divided by 2 is that formula. They are giving me 90 diagonals, so 90 is going to go in for D. And that's going to allow me to start solving for n. So 90 is going to equal n times n minus 3, all being divided by 2. So remember, to start this process, I want to get rid of the division. The opposite of dividing by 2 would be to multiply by 2. 2 times 90 is 180. That leaves me with my numerator, which I'm going to have to distribute. N times n is n squared. N times negative 3 is negative 3n. Because we are dealing with an n squared, an n, and a number, I got to get everything to one side. I want to keep that positive 1 in front of the n squared, so I move the number over to the other side. This creates an equation where it's now 0 equals n squared minus 3n minus 180. Because there's a 1 in front of the n squared, there's no number that those three terms have in common. Because that 180 doesn't have a variable, that means that they don't have any variables in common. So there is no GCF, which means we are asking ourselves, what is going to multiply to the last number, but add to the number in the middle? So we're creating a chart of factors that multiply to negative 180. So once again, that means one of my numbers has to be negative and one of them has to be positive. So if you start thinking about numbers, well, negative 18 and 10, that would multiply to negative 180. But notice that as I start adding these together, that's going to only get me negative 8. I want negative 3. So we have to think about two more numbers that are maybe closer to each other. Well, another way to multiply to a 180 would be 15 and 12. If I make the 15 negative and the 12 positive, notice that when I add those two numbers together, I'll get the negative 3 that I'm looking for. So these are the two numbers that are going to have to go in my factored portion of my problem. So it's an equation. It's going to equal 0. I want to start each of my factors with n, because once again, n times n is n squared. I'm going to make one of those parentheses have the negative 15. One of them is going to have the positive 15. I'm then going to set each of those equal to 0 to finish solving for n, which means we have to add 15 to both sides for the first equation, and we have to subtract 12 from the other. So we have two answers, a positive 15 and a negative 12. We're asked to name the polygon. There's no such thing as a negative number of sides, so the negative 12 does not fit, which means 15 is the number of sides. We have a name for that. That would be a pentadecagon. And that's my answer. Okay, if we take a look at this one, name the polygon that contains the following number of diagonals. Once again, 54 is going to be in for the D. Set it equal to the formula. See if you can pause the video and try this yourself. Okay, so hopefully you set that then equal to the n times n minus 3 over 2, multiplied both sides by 2, got 108 to equal n squared minus 3. Moved the 108 over by subtracting. We didn't have a GCF, so that told us what multiplies to negative 108 but adds to negative 3. That would be the number negative 12 and positive 9. So those are the numbers that go in each of my factors. I set each of those factors equal to 0, which then essentially changed their signs. I don't want negatives because there's no such thing as a negative amount of sides. So 12 would be my answer. The name of a 12-sided polygon would be a dodecagon. So that's us using formulas involving sides, angles, and diagonals of a polygon.